All right, so the first thing, there's a chart there, and it's got all of your rules all kind of combined into one spot. So we'll kind of go through them real quick, just kind of make sure you guys know what's going on here. First thing, I like to remember stupid ways to remember things. And the first one is MADS. It's like you got MADS disease because you hate math class so much, right? MADS, to me, always helps me remember what I'm doing with my exponents. So if it is a multiplication problem, that's what the M stands for, then you will add your exponents. If it's a division problem, then you will subtract your exponents. So some people need a way to remember things. That sometimes helps people remember that. Okay, so if it's a multiplication problem, you add exponents. If it's division, then you subtract your exponents. So that's what the very first one up there is talking about. And again, they have to be like terms, like these are both A's in order for you to put those together. But so you'll just keep that same base of an A, and then you take their exponents and you'll add them together because that's a multiplication problem. Power of a power property. If you think back, if I would give you 3 times x plus 2, what would you do? You would distribute. What operation is distributing? You're multiplying, right? You would do 3 times x and 3 times 2. So that same idea, when you have a number outside of a parenthesis, it's distributed inside. So this one kind of talks about more than one thing. First of all, if something does not have an exponent, there is a 1 there. So if it helps you write the 1, I'm never going to count off because you wrote the 1 in there. But then when you distribute, this gets distributed to both, and we discovered there's actually a typo. That should be an M right there. Okay, but you're distributing, you're multiplying the exponent in. But it's important to remember exponents only go to exponents, okay? But yeah, it's just multiplying when you're distributing. The negative exponent property, we talked a little bit about going over that one problem. If you have a negative exponent, we can't leave those. It's not simplified, so you just have to move it. So if it's in the top and it's negative, move it to the bottom. If it's in the bottom and it's negative, you move it back up to the top. So just moving it changes that. Quotient of powers property. These things are mouthfuls. If you're panicking right now over all of these names, like do you remember geometry and doing proofs and all that stuff? We don't do proofs. None. No proofs. Do I care if you remember all these fancy names? Nope. Don't care. All I care about is you know how to use them. Okay? So again, quotient, it just means it's division problem. So it goes back to the MADS disease. If it's division, you subtract. So you would take M minus N, subtract them. If it's division inside of here, the same way we distributed in this one, you'll do the same here. You'll distribute to the top, and you'll distribute to the bottom. And zero property, anything to the 0 power equals 1. So 7 to the 0 power equals 1 million to the 0 power equals 1. Carry in to the 0 power equals 1. I don't care what it is. Anything to the 0 power is 1. Yeah. Mm-hmm. You actually are keeping the common base. So in other words, let me kind of put this back in general term with numbers. If I gave you 2 squared times 2 to the 5th, what does that really mean? What's 2 squared mean? It means 2 times 2. Yeah, it is 4, but hang that thought for a minute. That means 2 times 2. And 2 to the 5th means I have 1, 2, 3, 4, 5. How many 2's do you have? You have 7. So you have 2 to the 7th. You're actually just adding these. You don't want to multiply them because I don't have 4 to the 7th. I don't have 7 4's. Right? I have 7 2's. So you keep that common base. It's almost like terms. You're just going to put them together and keep them together. Does that make sense? Right. Okay. So before we kind of get going into trying some of these problems, let's kind of go over, like, how do you know when to stop simplifying? You ever do that? You're working through a problem, and you're like, I think I'm done, maybe, I don't know. Can I leave it like that? Can I not? So simplified expressions do not contain blank exponents. Negative. Cannot have a negative exponent. So do not contain negative exponents. All right, they're considered not simplified. Or blank as an exponent. You guys are thinking too hard. 0. Anything to the 0 power is 1, so we can always simplify that. So don't leave 0. It has exponents that are blank numbers. Oh, I have one problem with whole numbers. What's the first whole number? 0 is the first whole number. Am I allowed to have 0 as an exponent? No. So I can't use the word whole. What? I could use positive. I take that. They're positive. They have number bases with an exponent of blank. So, for example, if you had 4 squared, would you leave it 4 squared? I hope you wouldn't. What would you turn that into? Turn that into 16. 4 squared is 16. What's the exponent on 16? It's a 1. So in other words, don't leave 3 to the third. Turn that into 27. Okay? So your numbers actually tell me what that equals. And has fractions that are, oh, that should be an easy one. Fractions can be negative. Really? Simplified. There we go. Yeah, make sure you're always simplifying your fractions. So if you have like 4 over 10, I hope you would turn that into 2 over 5, right? You would simplify those. All right, and I know some people are more of step-by-step kind of people. So let's go through and kind of outline some steps to kind of attack these. All right. Exponents are one of those things where you can do some things out of order and still get the right answer. Okay, that's why it's really hard to teach exponents sometimes. I'm going to give you what I would do in the order I would take things, knowing that you can do things slightly out of order. It's still not okay. First thing I would do is simplify inside parentheses. Simplify inside parentheses. Now, is it possible that you cannot simplify inside? Right, it's possible. So if you can, simplify inside your parentheses. After you simplify, I will distribute the exponent. All right, so if there's an exponent like a number 1 on the outside, I'll go ahead and distribute that. After you distribute, you want to combine like terms. Meaning it's got a common base, you can actually kind of put those together. Then you want to move any negative exponents. And simplify. That's kind of a general term because it depends on what the problem looks like. If you kind of follow those 5 steps, that should hopefully kind of at least guide you in the right direction on what to do when. Okay, so if I look at number 1, kind of going through my steps. So step 1, simplify inside the parentheses. Is anything inside there like a like term, common base I can put together? No. Okay, so I'm going to go to step 2, distribute the exponent. And again, if it helps you, this 2 does have an exponent of 1. If it helps you, put that in there so you don't forget that. We're going to distribute, so you will multiply. So we'll have 2 to the 4th. We'll distribute to the next one. It'll be x. 3 times 4 is 12. And then y, 4 times 2, 8. Okay, so I distributed my exponent. Next, combine any like terms. Anything alike that I can put together? No. Step 4, move any negative exponents. None. And then simplify. Is there anything I need to simplify? Yeah, that 2 to the 4th. 2 to the 4th is 16. Again, 2 to the 4th means 2 times 2 times 2 times 2, which will give me 16. You all right? You guys are real quiet. I can't read you. All right, take a look at number 2. We'll go through our steps again. So simplify inside the parentheses. Anything go together? Nope. Okay, so step 2, distribute the exponent. Again, that 5 does have an exponent of 1 on it, so don't forget. So we'll distribute. So we get 5. 1 times negative 2 is negative 2. Distribute to the next one. So we'll have a negative 3 times negative 2 makes positive 6. And then my b, negative 2 times 4 is negative 8. Okay, step 3, combine any like terms. There aren't any. Step 4, move any negative exponents. What needs to move? Good. So I need to move the 5 and the b. So right now this whole fraction is like over 1. So when I move things, the 5 is going to move to the bottom. And that becomes a positive 2. What do I do with the a? Keep it. Yeah, he's staying on top. He doesn't need to move. And then the b, we're going to move him down. B to the positive 8. So I got rid of my negatives. And then step 5, anything needs simplified? Good. 5 to the second, 5 squared. What is 5 squared? Good. 25, and then b to the 8. Not too scary so far? Some of them get a little frightening later, I'm not going to lie. Okay, so number 3. Somebody notice anything on number 3 right away? So anything to the 0 power equals 1. I like problems like that. A lot less work. All right, so number 4. Simplify inside the parentheses. Anything in each one go together? No. So step 2, distribute the exponent. Again, that negative 7 does have a 1 for it. So we'll get negative 7. 1 times negative 2 is negative 2. Take a little time out from this problem for me real quick. Notice how I wrote negative 7 to the negative 2 power. Did you guys put parentheses around yours? It's wrong if you don't. Real quick little side note for you. If you have negative 4 squared versus negative 4 squared, what's the difference? If you have a calculator, grab your calculator and type that in. Type in negative 4 squared without the parentheses and then negative 4 in parentheses squared. See what the difference is. No. What do you get with negative 4 squared without parentheses? What's this give you? This gives you negative 16. This one gives you positive 16. You're like, why? Your calculator is actually smarter than you want it to be. Okay? Exponents only go to whatever it's right next to. Okay? Unless you put it in parentheses. So looking at this little 2 is only on the 4, not the negative. What's it mean to square something? Times it by itself. So this is taking 4 times 4 and getting 16, and then multiplying that by a negative, turning it into negative 16. So even though you meant negative 4 is the number I want squared, you have to tell it by putting it in parentheses that the negative goes with the 4. Okay? So bottom line, if you're not sure, do I need a parenthesis or do I not, put it on there. Okay? You're never going to go wrong by putting the parenthesis on. But you will go wrong if you don't put the parentheses or on the negative. Okay? All right, back to this problem. So I distributed the -2. Distribute here. So we'll get m to the -6. Distribute to the n. So n to the -4. The other parentheses around the mn to the 7th, are those parentheses necessary? No, there's no exponent to be distributed. I don't really need them. So m, n. Yeah, you want one here? Absolutely. Yeah, if it makes you more comfortable to, so everything has an exponent, put it on there. All right, so that was step 2. Step 3, do you have any like terms? Yes, yes we do. Right, I have -7 to the -2 doesn't go to anything. But I have m's that go together. What am I going to do to their exponents? I'm going to add them. The only time you multiply exponents is if you're distributing. But yeah, this is a multiplication problem, so we add their exponents. So -6 plus 1 is -5. And then you also have n's. -4 plus 7 is 3. All right, so that was step 3. I collected my like terms, kind of cleaned it up. Step 4, move any negative exponents. Again, right now this whole thing's over 1. So what needs to move? -7 and m. Good. So the n to the 3rd can stay on the top, but I'm going to move the -7 squared down and m to the +5. Right, so I moved my exponents, and then step 5, simplify. What's -7 squared? 49. So n cubed over 49 m to the 5th. Now, it seems like a crazy amount of steps that we went through there. The more you do this and get comfortable, to be honest with you, I would have done this problem in like 2 steps. Because I could do a lot at once. So the more comfortable you get, the more you can kind of do things all together. All right, questions? All right. So number 5. Simplify inside the parentheses. We don't have any. Distribute the exponent. I didn't have any parentheses, so I don't have anything to distribute. Okay. Step 3, combine like terms. There aren't any. Okay. Move any negative exponents. Yes, what am I moving? Good. The y needs to go to the top. So we're going to move this up here. So I get -2x and then y to the 3rd. Do I need to move the -2? No, it's not an exponent. Some people panic like, oh, it's negative, I got to move it. It's just a number, okay? Only the negative exponents do we have to move. And then anything to simplify? No. We want a whole page of those on our test, right? Yeah, that was it. I just had to move the negative exponent. All right, number 6 is a very simple problem. However, the way it's written typically throws people. Right now, all of this is over 1. So that h to the 4th is technically it's on the bottom of your fraction, right? All right, so if I go through my steps, simplify inside parentheses, I don't have any, so then I don't distribute because I don't have any parentheses. Combine like terms, what's the same? Your h's. What am I doing with their exponents? Not cross multiplying. I'm subtracting them. Yeah, because technically, like, this is a very non-straight line. Technically, I got a big old fraction going on there. Okay, so it's actually a division problem. So when you're dividing, you subtract. 6 minus 4 is 2. And then I have k to the 5th. So don't let it throw you when they're written kind of weird like that. Just think of it all as a big fraction. That's actually on the bottom. If it's an equal sign, we're in a whole different chapter, and I'll teach you a whole lot more then. But yeah, for right now, we're not going to see an equal sign. We're just practicing our rules, so we're just going to have plain old stuff, no equals, no solving. All right, number 7. Why don't you guys try number 7 on your own? Give it a try. Let's see what happens. All right, let's go ahead and walk through it. Either you know what you were doing and you're good, or you're like, I'm not really sure where to go from here. All right, so step by step, simplify inside parentheses. Anything simplify from the start? Something does. You got A's in there. And I can look at it, I think a lot of you didn't do that first. That's okay, don't erase it, doesn't mean you're wrong. Don't erase. All right, so if I simplify first, my A's, 1 minus negative 6. What's 1 minus negative 6? Take a look at this. What would you do with this? You would add them. So it's actually 7. So I get A to the 7th, and then I have C to the 4th. Okay, so that would be what I would do first. And again, I'll look at it the other way in case you did without simplifying. All right, and then step 2 says distribute the exponent. So we're going to distribute, so we'll get 3 to the 3rd, right, distributing here. And then we'll get A to the 21st, C to the 12th, over 5 to the 3rd. Step 4, move any negative exponents. I don't have any. Step 5, simplify. 3 to the 3rd. Good, that's 27. A to the 21st, C to the 12th, all over 5 cubed. It's 125. You may have went a different route than me and still got the same answer. Okay, if you did not simplify inside here first, this is one of those times where this is the order I would have done it in, doesn't mean it's the only way to do it. Okay, if you distributed first, you could have. You'd have had 3 to the 3rd, A to the 3rd, C to the 12th, over 5 to the 3rd, and then A to the negative 18th. And then you would have combined like terms, so you would have put your A's together here. Then you would have 3 minus negative 18, which again would have been adding, and turn that into the 21 that I have up here. Okay, so you can still do it, doesn't matter. I just try to kind of clean it up first, which way it's less to distribute to. All right. All right, back to number 8. Let's go ahead and finish up the notes here quick. Number 8, step 1, simplify inside parentheses. Yes? No? No. Distribute the exponent. Yeah, let's do that. Again, remember that D does have a 1 on it. So we'll get D to the negative 1 over E to the negative 6. Where are the D to the 7th and E to the 3rd right now? Are they on top of the fraction or on bottom? They're on top. Technically, it's like they're over 1. So write them on top. It'll help you out. If you can kind of put all this as one fraction, it makes more sense to you. All right, step 3, combine like terms. Yeah, let's put the D's together. What do I do with their exponents? Technically, what am I doing? I'm adding. Negative 1 plus 7 is 6. And then my E's, what am I doing with those? Technically, I'm subtracting technically, right? Because I'm doing 3 minus negative 6. So I know I'm adding, but I was subtracting actually. So that'll change that. So it's E to the 9th. Move any negative exponents, simplify. I'm done. All right, 4 to go. 4 to go. All right, guys, when you have like a fraction times a fraction like this one's set up, what I'm going to recommend that you do is turn this into one big fraction. Okay, so it's like you have a top and I have a bottom. So don't think of it as two separate fractions, okay? There it goes. All right. So first thing, simplify inside parentheses. I don't have any. So distributing, I don't have any parentheses. Combine like terms. Now, when you have fractions where you got stuff on the top that's the same, stuff on the bottom, you got a lot, simplify the top, simplify the bottom, then put it together, okay? So on the top, I can put the y's. So we're having x to the 5th. Y times y is y squared. No, it's actually empty.
Okay.
Thank you. Where do I put this 3? Would you put it here? Would it be awkward with a big 3 right here? Be awkward to me. I'd probably put it right there. No, it's still on top. I just want to kind of get you guys in the habit of always put that number out in front. It just makes more sense to see it out there. Okay, on the bottom, can I put anything together on the bottom? Yeah, the 15 and the 4, what am I doing with those? We're multiplying. They're not exponents. So we're going to multiply 15 times 4, good, is 60. And we have y squared. All right, so I clean up the top, I clean up the bottom, but can I clean up them together now? Yeah. What's going to happen to my y's? What do I do with their exponents? Subtract. What's 2 minus 2? And what's anything to the 0 power? 1. So do I have to write it? No. It's kind of like you look at it like y squared over y squared. They kind of cancel out, right? What about the 3 and the 60? Can I simplify them? Divided by what? Right, top divided by bottom. So 3 divided by 60. But just simplify the fraction. I can divide them both by what number? By 3. So 3 divided by 3 is 1. 60 divided by 3 is 20. So really, if I look at this, I have an x to the 5th on top, a 1 if you want the 1 with it, and a 20 on the bottom. And that's all I got left. All right, so number 10, same thing. Go ahead and turn that into one big fraction. It's going to make it a lot easier for you. Okay, so go through step by step again. So simplify inside parenthesis. Nope. Step 2, distribute your exponent. We can do that. So we get 3 to the negative 2, m to the negative 2, and then n to the 4th. I still have an 18, an m to the 5th. On the bottom, I got all of this stuff going on. Oop. Actually, can I put something together on the bottom? Well, hold on. I'll do one step at a time. Sorry. I don't want to confuse some of you. So the only thing I've done at this point was distribute. Okay, we'll just go one step at a time. All right, so next is combining like terms. So again, let's do the top, and then we'll do the bottom, and then we'll do it together. So on the top, what can I put together? I have m's, right? I can put those m's together. What's m to the negative 2 and m to the 5th? Good, that's m to the 3rd. So that boring? I'm sorry. All right, and then I have an n to the 4th, and I have that 18. Can I multiply the 3 to the negative 2 times 18? I can't, only because this has this darn negative 2 as an exponent. I can't actually multiply those together. All right, how about the bottom? What can I put together? The n's? All right, so n to the 9th and n to the negative 2 gives me n to the 7th. All right, I have an m. Can I put the 10 and the 2? 20. Notice I could put the 10 and multiply it by the 2 because they didn't have any weird exponents on them, so I can go ahead and put those together. All right, I'm still in the combined like terms. Can I do anything now top and bottom together? Yeah, I can do the m's. Right, so my m's, the exponent's a 1, so 3 minus 1 is 2, so it's an m squared. My n's, 4 minus 7. So where do I put it? On the bottom, and it would become a positive once I move it down there. Typically when you're putting stuff together, if it's positive, put it on top. If it's negative, throw it on the bottom. Okay. How about this 18 and the 20? Yeah, I could divide them both by... Nobody does? 2. Divide both by 2. 18 divided by 2 is 9. 20 divided by 2 is 10. I still have this 3 to the negative 2 going on there. So step 4 says to move those negative exponents. So now I can actually move it down. So m squared and that 9 stay on top. Move this one down. 3 squared. And again, I hope you're noticing I'm doing this in very tiny steps for you. If you were doing this on your own, as you get more comfortable, you'd probably do a little more steps at once. What is 3 squared? What's 3 squared? That's 9. So if I have 9 m squared over 9 times 10n cubed, what happens to those 9s? They cancel out. So your final answer, m squared over 10n cubed. Whew, that was probably the most intense one we've had so far. But you see how we kind of go just one step at a time. Don't feel like you got to answer the whole problem in one step. Some of you like, I don't want to show any work, I want to do it all in my head. Don't do that, okay? Write things down. It's okay. Questions on that one? I know that one got a little ugly in the middle. Doing okay? Yay? Thumbs up, thumbs down, somewhere in between? Where are we at here, guys? I can't read you. I got a shaking one. All right, okay. Last two. Last two. I knew you'd be excited. All right, so number 11. Right now, think about, I got a fraction and I got something that's not a fraction. Where is it really? Top or bottom? It's on the top. All right, so right now this is all on the top of that fraction. So again, let's go through our steps. All right, so going through our steps, simplify inside parentheses. So can you put any of that together? Nope. An R, an S, and a T, they're all different. Step 2, distribute by exponent. So let's go ahead and distribute. This stuff is not changing. I'm just going to rewrite it so I don't lose it. All right, so if I distribute this, we're going to multiply. 3 times negative 2 is negative 6. You get S to the negative 2, and then T to the 8. All right, so I just distributed my exponent. Step 3, combining like terms. Again, let's kind of clean it up a little bit. What can you put together? The R's? Good. We'll start with those. So what am I doing with my exponents? I'm adding them. What's 2 plus negative 6? Negative 4. Anything else I can put together? In the whole fraction? The T's? What am I doing with their exponents? It's division, so it's subtracting. What's 8 minus 9? Negative 1, so where should I put it? In the bottom. See the first. What about my S's? What's this one? Anything to the 0 power equals 1, so do I really need this? No, it's like it's not even there. So I have s to the negative 2 on top. Step 4, move any negative exponents. Yeah, so I need to move these to the bottom. 2 is going to stay up there. Then the r needs to come down, r to the 4th. The s needs to come down, s squared. And then the t is still on the bottom. All right, I don't know if you guys are anal like me, but it drives me nuts that 2 is not centered. Does that bother anybody else? Okay, a couple of you. All right, you understand my struggle with that? All right, 1 to go. Try it on your own? No! Yes, on your own. See how we do. That one's not that bad. All right, so last problem. Step 1, simplify inside the parentheses. Walking around, some of you did not do that as your first step. Okay, that's fine if you didn't, but I'm going to do it that way. So inside my parentheses, I have a's. So 4 minus 3 is 1, so it's a to the first. My b's, 7 minus negative 1 is actually 8, so b to the 8th. And then my c's, 6 minus negative 3 is 9. And suddenly this problem doesn't look quite so scary. If you did it the other way, just hang tight. It's okay. The other way is to distribute this to everything first, then put stuff together. And that's okay. You can still end up the same spot. All right, so now I'll distribute. So we get a to the negative 2, b to the negative 16, c to the negative 18. Okay, there's no other like terms. Moving my negative exponents, they all need to move. Positive a squared, b to the 16th, c to the 18th. Nothing simplifies. I am done. Okay, if you distribute it to everything first, that's okay. You just got bigger numbers to work with when you put them together. You missed the a and the c? But you combine the b's together? Interesting.